Hi, myself Naveen Kumar Saini. Today in the course of wireless and mobile communication REC 085, in the lecture 2 we will discuss the general model of wireless communication link. So, as we know, the wireless communication is nothing but is the unwired. Okay. So, there are some learning models which is interdisciplinary cases are there. So, in that the wireless digital communication part which is centered of the wireless communication. So, there are different prerequisites to know about the wireless digital communication and its block diagram. So, for that it is divided into some blocks. So, in that like communication theory, digital signal processing, radio wave propagation, cellular theory, mathematics, probability theory, signals and systems, information theory and coding. So, these all are the prerequisites to know about the wireless digital communication system or the general model of the wireless communication. So, in that the basic terms which is used for fundamentally to know about the blocks of wireless communication. So, few terms are there just like information. So, this information may be analog or digital, from it can be from the messages or it is a meaningful data to be received. So, this is the information just like if I am talking. So, my voice is one of the information. So, how we can travel this voice from one point to another point. So, for that the information takes place into consideration. Next is the modulation. So, what is a modulation? It is a process by which a signal is transformed into the waveforms that are compatible with the channel requirements. So, this is one of the main factor in the wireless or any kind of communication system where modulation can takes place. Without modulation we cannot transmit the signal from one point to another point for the long distance. Next is the carrier. So, carrier it is a frequency over which the actual communication is done. So, this carrier is the part through which the modulation can takes place. Next is the transmitter. So, this is a system that prepares the signal to transmit over the channel. Okay. So, next is the channel. So, the channel which is through which the signal can be propagated. Next is the receiver. So, it is a system that receives the signals and interpret the messages. So, if we say there are basic three blocks of the communication system. So, first is the transmitter, second is the channel, third one is the receiver. Okay. So, this information or modulation can takes place through the transmitter part, and when we talk about the channel, so channel can be of any kind of things, any kind. So, just like your wired channel is also there, maybe optical fiber is one of the channel. Okay. So, if we create the satellite link itself, this is one of the channel is there. So, the different type of channels are there, and those channels are noisy in nature. Next block is the receiver. So, receive all the blocks, all the functionality which is happening in the transmitter, it will in the reverse order it will happen in the receiver to receive the original signal. So, the channel which is generally used in the wireless communication may be of a simplex, half duplex, full duplex. So, what is a simplex channel? So, it is a one way of communication. There is only the transmitter can send the signal to the receiver. Second one is the bidirectional, or sorry, it is a half duplex. So, in the half duplex it is bidirectional, but on the switching basis. At a time transmitter can transmit the signal or it can receive the signal at another time. Okay. Same thing is happening with the receiver. So, that receiver can be at one time it will receive the signal, at another time it can transmit the signal. So, this is the half duplex. Third one is the full duplex. So, in the full duplex it is a bidirectional, and the simultaneously we can transmit the signal from one point to another point, or it can receive also at the same time. So, this is the full duplex or the bidirectional. Okay, so in addition to the signal in the channel, when we talk about, so that signal will be noisy at the receiver. So how it will be noisy? So it will be noisy when the transmitter is sending that signal into the channel. So channel, if this channel is some noisy characteristics are there, then that choice will be that noise will be additive to the signal. So in that case, you can see if there is a plane wave is like this one. So sorry, so we can say if the information which is sorry, so these things which we have covered. So transmitted signal, as it is noisy in nature, so it will be received with the noise here. Okay, so we can see this is a plane signal, this is noise which is added through the channel, and this is a received signal. So this is a noise which is added. So this is added with the channel noise. Okay, so this is added with the channel in the wireless channel we are talking about. Okay, so the received signal will be noisy in nature. Okay, so now come to the point of the general model of the wireless communication link. So in that we can see the first block. So you can say the first section from here to here is the transmitter. Okay, and here this is the channel, and this section from here to here, this is complete the receiver section. So in the transmitter block or transmitter section, there are some different sub blocks are there. What are those? First one is the information source encoder, so information source encoder, then encrypter, channel encoder, and the modulator. And at the transmitter side itself, there is the RF up conversion, where we use the antennas. Okay, so these are antennas which will use. Now that signal will be transmitted through the channel, and this channel will be received. Also, this information which is passing through the channel, it is received at the RF down conversion. So this RF down conversion also use the antennas. Okay, after that the receiver block is there, which is comprised of demodulator, channel decoder, decrypter, source decoder, information sink. So we will discuss each and every block in the transmitter side, about the channel, and the receiver side. So first one is the information channel, information source. So this information source is the signal or the information, just like our voice, as I have given the example. So this voice is the signal which is transmitted, which is sending, we want to send it through the transmitter, and this same voice must be get it at the receiver. Okay, so at this time this information source will be, just for example, it will be the voice. Then there is another block, there is a source encoder. So right now it may be the analog signal. At this point, this will be the analog. Okay, then we are using the source encoder. So this source encoder is used for reduce the redundancy. Okay, so for that there are different source encoder algorithms are there, just like Huffman coding or Shannon-Fano coding. These are the algorithms which are used for the channel encoder. So at this point, here itself, the signal which is received after the source encoder, it will be the digital signal. So this will be the digital. Okay, then we will do encrypter. So what is the functionality of the encrypter is? So it only provide the ciphers. The plain text will be converted into a cipher text, or in other simple language we can say this encryptor will convert the meaningful information or the readable information to the unreadable or the meaningless, so that when we transmit it into the channel, so it cannot be retrieved, or for security point of view we use the encryptor. Okay. Then we have the another block, that is a channel encoder. So whatever information we have converted from analog to digital, so it will be reached up to the channel encoder. So this channel encoder is what? This is used for reduce the noise immunity. Okay, so it will reduce the noise, okay, which is coming from the these sections, previous sections. So for that we have the different algorithms also for the channel encoders, like the block code, cyclic code. These are the examples for the channel encoder. So what is that now? If we have any information like 0 1 0 1, then we will provide the some redundancy in the channel encoder. So that may be, suppose you are adding these bits as 0 1 1. So this was the information which is coming from here, from this digital 0 1 0 1, and when it is coming into the channel encoder, so in that case we add the some other redundancy bits, that is 0 1 0 1 1. Okay, so the complete information is now the 0 1 0 1 0 1 1. Okay, then we will provide the modulator. So this modulator will modulate this information into the carrier. Okay, so this carrier will provide the modulated signal to this information bits. So there are the various modulation schemes are also available, just like AM, I mean, so the DM delta modulator or the adaptive delta modulator. These are the examples which through which the modulation can be takes place. Next is the RF up conversion. So this RF up conversion is doing like if you want to transmit the signal for long distance, so for that one, so for RF conversion it will convert the low frequency signals into the high frequency signals. Okay, so it will up converse, so that we can transmit or we can pump through the power to that signal for the long distance. Okay, without RF up conversion we cannot send the signals from one point to for long distance to another point. Okay, so for that purpose we use the RF up conversions. Then so for that one we use the antennas. Okay, so different type of antenna schemes are also there, just like MIMO concept we will study in upcoming lectures. Okay, multiple input, multiple output. These are one of the structure through which the more and more speed data can be transmitted. Okay, so more and more data can be transmitted in that way. Okay, so but another way, what point I want to tell you, that about the modulator itself. The modulator, it also modulate this bit stream into the to provide the more to transmit the more data with a more data rate. So for that purpose we use the modulator itself. Okay, then when it is passing through the wireless channel, so this channel which comprises the noise itself, in that you can see. Okay, so in the wireless channel the noise is also added in with the signal which is transmitted from the source encoder or the encryptor and the channel encoder. Then after that there is the RF down conversion. So for that block, whatever signal we have transmitted through this RF up conversion which is of high frequency, now it is reduced to the lower frequency, so that because all our signals when we transmit, like our voice, this is low frequency signals. Okay, so when RF down conversion we are doing it, so in that way the higher frequency which is of in gigahertz, it will be converted into the lower frequency signal like kilohertz. Okay, so it is done by the RF down conversion. Then after that we use the demodulator. So this demodulator is just opposite of the modulator. Just like if you are using the frequency modulation, just for example, if you are doing the frequency modulation at the modulator, then we will use the we will demodulate that frequency modulator scheme. So opposite of the modulation, right, we will perform it in demodulator. Then at here itself the signal which is coming, that is your 0 1 0 1 0 1 1. Okay. So, this is a signal which is added, but what is our information right now? It's still our information is this one 0 1 0 1, fine. Now, it is coming to the channel decoder. Now, this information is coming to the channel decoder. So, what this channel decoder does? So, this channel decoder performance the channel decoder convert this complete stream 0 1 0 0 1 0 1 0 1 1 into the main signal, that is 0 1 0 1. It will reduce the added redundancy bits, that is 0 1 1. Okay. Then decrypter, what it does? Basically, this encryptor does the opposite of the encryptor. So, where the encryptor has converted the main information into the some ziggy, or you can say some distributed this information, like if we are sending 0 1 0 1, so it can be changed to 1 0 like that, 1 0 1 0 kind of. Okay. So, to come into the original condition, so we use the decryptors. Okay. So, in that case, then we will use the source decoder. Okay. Source decoder, again it is the opposite of the source encoder. So, there are different algorithms also available for the source decoder. So, finally, it will come to the information sink. Okay. So, the whatever the original signal which is transmitted from here, the original signal, this is the original signal. So, it may be your empty. Okay. So, it will receive the same empty original signal as the information sink. So, this is the complete block diagram of the wireless communication link between the source to the destination, or the source to sink, or this is the your transmitter and this is your receiver. Okay. So, there are some other parameters which is used for this for explaining all this, which I have just covered: source, encoder and decoder. So, encoder, it does the job of the digitization, as I said, analog to digital conversion, and the compression as per the information theory. So, what is the compression? Just like data compression. So, data compression also can be takes place through the in the source encoder. Okay. So, encrypter and decrypter, which are the secure presentation of the message. As I said, we use a ciphertext for the encryption and the decryption. Okay. Next is the channel coder, decoder. So, channel coder and decoder, it adds the structure redundancy to mitigate the channel errors. So, this to reduce the noise or to reduce the errors, we use the redundancy, all the redundancy bits we can add it out, and decoder, it tries to remove the errors. Then other pair stages of modulator and demodulator, and the RF and IF frequency, IF to RF frequency up conversion at the transmitting end, and the RF down conversion at the receiving end can be takes place. Okay. So, in this way we can perform this complete block diagram of the wireless communication system. So, it is all about. And then next point is the some at the transmitting side itself, sending training sequences for the channel estimation and equalization, and also for the synchronization. Okay. So, training sequences are just like sequence of ones and zeros. Okay. So, those sequences can be add on at the transmitter, so that when it is received at the receiver, so it can be detected carefully, or it can be detected correctly, right. Next is the filtering for allowing certain frequencies, pulse shaping to reduce the bandwidth, and windowing to reduce out of the band components, which are few actions at the transmitter end. Okay. Next is some other things about to know in about the these blocks, the peer and reverse task of that transmitter which mentioned in the previous slide, as I mentioned, performed at the receiver. Okay. So, as in the previous slide you have seen the general model, in that the transmitter has some functionality like the information, then source encoder, channel encoder, encryptor, channel encoder, then modulator. So, same in the reverse order is happening in the receiver side. Okay. So, apart from that estimation and equalization process for the channel condition corrections and phase corrections respectively. So, these are some characteristics, receiver characteristics. So, what are those? Sensitivity, selectivity, fidelity and noise figure. So, these all four are the few characteristics about the receiver side. Now, next is another very important point in the block diagram about wireless communication, that is the bandwidth. So, as we know, whatever bandwidth resources is available with us, so we have to utilize that resources. Okay. So, one of the resource which we have, that is the bandwidth. So, basic definition of the bandwidth is what? The spectrum which of a signal is the collective representation of all the frequency component contents along with their amplitude weights. Okay. So, it is used to characterize a signal which can be the input signal as well as the baseband or the broadband to be transmitted, and correspondingly this is called a signal or the transmission bandwidth. Okay. So, there are two things which is different. First one is the signal or the 0101 bit which has the different bandwidth, and the channel bandwidth is also there. So, for that we have to compare the bandwidth. Okay. So, the bandwidth of the signal must be less than the bandwidth of the channel. If the bandwidth of the signal is more than the bandwidth of the channel, in that case we cannot transmit the signal perfectly. So, for that we have to check the bandwidth of the signal and bandwidth of the channel. So, I will in between I will just discuss it about the more about the bandwidth. So, what is that? So, we call the coherence bandwidth. Okay. So, signal or the transmission bandwidth, and second channel has the coherence bandwidth. So, the transmission bandwidth which is of signal must be less than the bandwidth coherence bandwidth of the channel. Okay. So, for proper transmission of the signal. So, in that the channel which is allocated to the user or application which is identified as the channel bandwidth. Okay, as I said, then while designing the transceiver hardware or the certain, or you can see the certain frequency components which are allowed, which is called the system bandwidth, and the transmission or system bandwidths must be less than or equal to the channel bandwidth, as I said just now about the transmission of the for proper transmission of the signal into the channel, so that there should not be any loss of the bits into the channel. So, for that purpose the transmission bandwidth must be equal to or less than the channel bandwidth. So, the different type of noises can occur when the transmission bandwidth is more than the channel bandwidth. Some noise is there, and then the error can be introduced more, or it can be the signal may be reduced. Okay, signal information may be reduced. Okay, so proper way, in the proper way the signal cannot be transmitted. So, these are the terms which are used in the transmission of the signals. So, some terms are also there, that is a bit rate, symbol rate and the baud rate. So, bit, which is one of the smallest element or the unit in the representing any binary level of a digital signal. So, digital data that transfers is normally measured in bits per second. Okay. So, this is the data rate or the bit rate, that is the bits per second, and group of bits is called a symbol or the words. Okay. Suppose there is the only one bit we are transmitting 1, 2, 4 bits like that. So, 4 bits if you are transmitting per second, then this is the 4 bits per second. If 1 bit at a time we are transmitting, then it will be the 1 bit per second. If we are transmitting in a bulk of the bits, so we call it as a will transmit in a symbols, right. So, when the number of bits which are processed together at the modulator front and for the amplitude and phase mapping. So, they are called the symbols, and rate of transfer is measured into the symbol rate and measured in symbols per second unit. So, this is representing this with this diagram, also with this formula. So, the formula is representing the symbol rate, that is equal to the bit rate divided by the number of bits transmitted with the each symbol. Okay. So, in that you can see that the bit rate divided by number of bits transmitted with the each symbol, and the each symbol represent the m finite stages, and each symbol represent the k bits of information, where. So, the for formula for that will become the k is equal to logarithmic of m base 2. Okay. So, next point is the baud rate. So, baud rate is the rate of change of signaling or electrical voltage level transmitted per second. So, this is the very important points about the transmission of the signals, because the transmission of signals is how we can measure it. So, we can measure it in terms of the data rates. So, these data rates can be of your bit rate, your symbol rate, your baud rate. So, these three are the representation of the data rates. So, we will start about the introduction of signals and its type. So, in the basic term we will only explain now. So, next lecture we will discuss about in elaborated form of the signals and its type. So, as we said, what are the signals? So, signals are the function or the more independent variables that carry some information to represent a physical phenomena. Okay. So, as I have given the signal as a voice, but here itself the signal can be of ECG, okay, or EEG, just like electrocardiogram, electroencephalogram. Okay. So, these are the examples of the signals. So, different types of signals are available in our syllabus which we will study. So, all these signal types we will study. Okay. Thank you very much from my side. Thank you.